So today you'll only have a lecture. Okay, I think this is the one. Okay, so I'm supposed to give an evaluation of exercise 3, but unfortunately, I was not able to finish checking all the papers, and I'm not really prepared to show any example. So I'll just tell you what are expected in these exercises. In the first one, this is more of angular dimension, which actually I forgot to teach you about angles. But some figures here, like for example, the one in the middle, you can put all the um, linear dimension, but it's also useful to have angles if you do not want to the dimension lines to cross. I'll be showing you, I'm working on an AutoCAD version of the solution, and I'll be sharing it with you after our session, but maybe not today, maybe tomorrow. In this exercise, of course, we have notes here on the top, which you will have to follow, but this one is more about radius. Okay, arcs are dimensioned as radius. That's what we learned the last time. And for this one, the circles, of course, are dimensioned in terms of diameter. Um, okay, so these exercises are not really very appropriate for architects because, as you can see, it's more of mechanical drawings. But your exam will definitely be architectural. Anyway, the same principle applies. Let's go directly to our topic, which is about scaling. This is one of those very confusing topics because it involves a little math. You know, architects are not very good in math generally. So to scale simply means that every element in a drawing or model is in the same proportion with the same relationships as as than the existing real or proposed, but that it is smaller or larger by a certain percentage depending on the paper or printable sizes. So basically what it's saying here is that there is an equivalent size of the real world to a particular to fit a particular purpose, like to fit in a paper. So there is an equivalent size which is proportionate. So how do you make that size? So that's called scaling. um, for us, we will need this triangular metric scale, and well, in the slides you can see how it would look like, but I think I have another version. This one, no? This is how it looks like, and I hope you bought one because you'll be needing that throughout the course. I mean, throughout the program, no? The architecture program until you graduate. Um, Although you'll be using AutoCAD in higher years, but they are actually very helpful even during construction. Even me, I still use the triangular metric scale until now, no? Even when my drawings are printed in CAD. So we represent scale using the mathematical ways to show relationships, or what we call the ratio. So in the scale, if you have it, you will notice that in the corner, you see the scale there. 1 is to 20, 1 is to 25, 1 is to 50. So a metric scale normally has six sides or 6 rulers. So, and this is the common one. We actually try to avoid the 1 is to 25, 1 is to 75, and 125 because they're very difficult to figure out in terms of when you don't have a triangular metric scale, you can actually use the normal ruler with centimeters. But then when it comes to this sort of scale, 1:25, 1:75, it's a bit difficult to make a ruler, a scale ruler on based on the 1:100 ruler. I'll show you that later on. Um, so this is the metric scale, and then there's also what we call an architectural scale. It's funny because the architectural scale is in terms of English standards. So the scale is in terms of fraction. So 1:1/2, 1:1/4, and then we don't use that. Okay. Um, there are scales like the one you see in the picture. You see both two scales. One is to 10 and one is to 100 at the bottom. It's because the conversion is very easy. You just add or remove a zero, then you can use the um, one of the scales. So important consideration to know the dimension size of the space or item being measured. Once the size of the drawing has been ascertained, select the desired scale on the metric scale. And metric scale calibration is used according to the American National Standard Institute. So the International System of Units, linear measurement, which is commonly used on drawings, is the millimeter. So um, we're going to use millimeter. Okay. Uh, the it's important for you to know the overall size of what you're going to draw so that you can choose the best scale to fit your paper. Because with the, for example, if the house is like 10-meter wide and then the height is something like 7 meters. So in the scale, in the paper, experimenting on the scale, you can already see which scale would fit that those dimensions. And then, of course, you have to add allowances for the dimensions, um, and then the labels. So you're not going to fit it exactly in the paper, so you have to add some space around it. So that's one way of doing it, unless, of course, the scale is already specified by the instructor in our class, or as I will show you later, in the practice, there are actually standard scales to use depending on the drawing that you're going to make. So it's like automatic. Sometimes what you need to adjust is the paper instead of the drawing because it has to be drawn on this particular scale. And then also if even the paper cannot take on the scale, so there are ways of breaking up the drawing so that it fits the papers, but then in the end it's still understandable. How to use your metric scale? Okay. So in a scale of 1:1 meter, this is the actual dimension. So you have your ruler. I don't have a ruler. So if you have a ruler and then you look at the calibration, so you will see there, I think 10, 20, 30, and like the ones at the bottom of the drawing. And then those are centimeters. Those are millimeters, okay? Or if the calibration is 1, 2, 3, those are centimeters. But then, in a scale of 1:20, you're going to divide your 1 meter by 20. And then the result is your 1 meter in a scale 1:20. Okay, I'll show that to you in this next slide. So here, on top is your ruler in um, 1:1. Okay, this one here is 1 centimeter, 2 centimeter, 3, etc., etc. But then if I divide 1 meter or 100 centimeters by 20, we get 5 centimeters or 0.05 meters. But let's stick to centimeters. Okay, so this 5 centimeter is your 1 meter in a scale of 1 is to 20. So if you're going to draw a line, which is 1 meter in the real world, and you're going to draw it on your paper in a scale of 1 is to 20, um, so you either follow your triangular metric scale, you have a 1 here, or if you don't have that, you can use an ordinary ruler with 1 is to 100 or 1 is to 1 in centimeter. You just mark off 5 as your 1 meter. So I hope that's understandable. No? It's the same thing with whatever scale you're using. If it's 1 is to 50, you divide 100 centimeter by 50, and then you get the equivalent of 1 meter in a 1 is to 50 scale. Okay, so, but then, of course, you only do that if you do not have the triangular metric scale. The greater the scale, the smaller the drawing. Okay. For example, you have a 1 is to 1 meter. This is greater than 1 is to 75. The 75 is greater than 1, but in terms of the scaling, the bigger the scale, the smaller the drawing. So 1 is to 75 is greater than 1 is to 100. 1 is to 100 is greater than 1 is to 200. So therefore, if I ask you to draw something at a scale, a particular scale, and it did not fit the paper, maybe you used the wrong scale or you interpreted it wrongly. So this is example. This one is 1 is to 76.2. Um, well, I think these are drawings on toys because you know if you buy these toys, they also have scale, and the scale is um, difficult to understand. It's like 76.2, 1 is to 64. But here you can see that 1 is to 76.2 is smaller than 1 is to 64, and this one is smaller than 1 is to 43.5. Okay, just an example. Okay, so earlier I mentioned to you that the scale to use may depend on what drawings you're going to make, and there is an industry standard for it. The least detailed, like 1 is to 200, is sometimes used for concept plans. And then getting bigger, you'll have the building permit plan, 1 is to 100, and then the construction plan, 1 is to 50. Then you have detailed construction plans, which is done in 1 is to 25 or 1 is to 20. And then the most detailed are construction details. I have a more detailed version of this. This is a site plan. Site plan or site development plan is usually done in scale of 1 is to 100 or higher. So sometimes if your drawing, if your floor plans are 1 is to 100, your site plan is the drawing smaller. No, because the focus is more of the what's outside the proper the structure. So what's within the property but outside of the structure. So for floor plans, elevations, and sections, if the drawing is for, as mentioned earlier, for building permits, so it's enough to give a 1 is to 100 drawing, okay? Because what the office of the building official will look for is more of the overall sizes, whether they follow the building code or some setbacks. So they don't necessarily look for details. But then if the drawing is for construction, so the plan has to be 1 is to 50. Because in construction, you look at all the details. If you blow up a room, which we call detailed room plans, you can use 1 is to 50 if your floor plan is 1 is to 100, or if your floor plan is 1 is to 50, then you can use a 1 is to 20 um, scale, especially if you are using, if you plan to um, show layouts of furniture. But in the construction drawing, you don't show the furniture. You only show the architectural features like the walls, whatever is built in. So anything which is movable is not shown unless you need to indicate that it is located here. Like the refrigerator has to be located here, it cannot be located anywhere else. The bed, you can locate it anywhere, so you don't have to show it in outline. Um, so what I'm showing here is more of an architectural drawing. Therefore, um, the focus is more on the layout. Okay. Construction detail. So you will be drawing so many things. Therefore, the scale to use is usually between 1 is to 20 to 1 is to 5. So as big as 1 is to 5. Because as you can see here in the example, there are so many notes, so many dimensions, and so many other details, no? Like the drain, and then also the insulation. Then you'll have to learn all of these symbols later on. Um, then these are what we call spot details. Okay, so in your section, for example, you encircle an area because you're going to make a detail, and so you show the detail like this. So that's a spot detail. Now, full-scale pattern, especially if you are making a furniture, when you make a furniture, you have to make the actual size, a drawing of the actual size, because the carpenters are going to just trace over it. It's like making a dress, so you have to make the actual size, full pattern, because they're going to cut according to the actual shape. Um, Here in my work, we also do this because um, we're restoring an old church which has some carvings, for example, and then we have to replicate the carving. So we have to trace it and then to draw it 1 is to 1 scale so that the carvers would follow it. It's the same with wood and also with stone. Okay, they ask me for 1 is to 1 drawing, and then they trace that over the wood or on the stone, and then they carve it. So we also make 1 is to 1 drawing. And sometimes I saw in the internet, um, there are architectural firms that actually make a 1 is to 1 layout of the whole house so that their client can make a almost like a actual walkthrough on the size, because unfortunately not all clients have that sense of space. No matter how much you describe it, they just can't get it. And in the end, although they approve the drawing, when it's built, they find it too small or too big. Okay. So another way, of course, is to actually make them enter a room with the same dimension, so you don't have to draw it. So you just figure out where is a similar space, no, a similar sized room, so that when they enter, they have the sense of space. Now, perspectives should not be scaled unless you're doing a multi-point perspective method, which I used to teach in graphics 3. But this one is, and I think I noticed that a lot of the students nowadays make use of SketchUp. So they draw everything in SketchUp, whether detailed or just blocks, and then they generate the perspective, and then they trace over it, and then they put in the details. Or they, if the 3D model is very detailed, so they just trace the perspective. But in my days, so you can make a perspective using the what they call the method, no, mata-mata method. So after doing a lot of perspectives, for example, measured perspective, the way it's taught to you in graphics, um, you end up knowing or having already a sense of the proportion of the drawing, okay, so that you actually can end up um, making the drawing even without a scale. This is what you do when you do outside sketching. Okay, so you just sketch it according to how you saw it. What you're actually doing is making a perspective, and you're not actually um, measuring it. Okay, because there are problems with measured perspective. Unless you know this method, you cannot predict how small your drawing would look like or how big. You cannot predict the output. Um, but if you use this method, multi-point perspective, I saw a book. It's being published by UAP before, and I studied it. They have a way of determining what scale your perspective should be, depending on the size of the drawing you want, the output you want. Okay, and then you can actually generate the perspective in detail and in with measurement, with detailed measurement. Now we also have, if we're going to submit a plan for the building official, we will be asked to include a location map or vicinity map. Okay. The main reason for the vicinity map is for the building official to know where the project is so that he can visit. So this will be his guide. So therefore, there has to be landmarks, starting from a very familiar place and then going to inside the whatever, until the project site. In this case, the arrows are not actually necessary. Uh, and then normally, instead of here in the example that I showed you, they put there a seal of the, what is this, college, San Beda College. But this is more for a magazine. But in the technical drawing, you just point to the property and then say that this is the site, no, this site. And you don't need to put all the arrows. But you need to put some of the buildings which will serve as the landmark, and you also need to put the names of the streets. And then what's most important is that it does not have to be scaled. Okay, so like it's just a map. It's just a location map simply. Um, A map that should be scaled is something that which is used especially for GIS or for planning purposes. But the type of scale, the scale to use will again differ on what map you're going to use. Okay, because if you're just making use of a land use map or a um, um, for analysis like vegetation map, etc. So without detail, it just shows you the area, which one is residential, which one is commercial. So the drawing is normally small. But then if you have to show like contours, so the and plots like this one, you see the lots, so the drawing is bigger. Okay. Now, when you draw something in different scales, the detail also changes. Here we have, I'm showing you 4 examples. An example of a reinforced concrete pillar, door, a window, and in plan and window in elevation. So the drawing is too small, so you can just put the very basic. Okay, in the case of a window, you just put that the wall is thick, the section, and then there are a few lines to represent the window, and that one line at the middle is the center point of the center line of the window, depending on how you dimension your drawing. Then in elevation, it's a simple rectangle. But then when the drawing is bigger, like 1 is to 100, so your elevation window can show the jambs, and then it can also show the, um, the direction, I mean the location of the hinge, that arrow, that outlined arrow. In the door, you can see more details. Um, and then when it becomes 1 is to 50, so more details. No? Even the jump in the elevation, the window has more details. And then when you reach 1 is to 25, 1 is to 10, or 1 is to 5, you can see that even in plan, you see the design of the jump already, of the windows and the doors. And then even the leaf of the door already has a particular thickness. Okay, and then the pillar, you can see now the hatch. There's a symbol that tells you what material this is, and that differs it from the wall. So that's what happens when you make the drawings. That's the disadvantage of using AutoCAD. Okay, because in AutoCAD you draw only in model space, but then when you print it, you can print the same plan in different scales. But then when you print it in smaller scale, or when the drawing is big, so you tend to put so many details. But then when you have to print it also in a bigger scale, or the drawings are smaller, so all those details are still there. Okay, so you have to learn. There is actually a way in AutoCAD so that when the drawing is smaller, some details are not shown. But then you will have to learn it. And unfortunately, most of the AutoCAD users do not bother. So they end up doing it manually, like making two drawings, one actually small or detailed, one actually not. So it's very inefficient. So you have to learn how to to use CAD properly so that everything is really efficient. And that brings us to a problem later on, which I will show you. Um, because supposedly this Thursday, our lesson will be about AutoCAD. But I'm still comparing with with the other teachers, because they also don't seem to know what to do. Um, when it's not online, of course, we do things manually with the drafting studios, and then there's always a time when we also learn AutoCAD, and we go to the computer laboratory. But then here, there's no computer lab, there's no drafting studios. Your drafting studio is your place there at home. Um, and I don't know how to go about it yet. Okay, so we'll discuss that maybe next meeting. Um, but in principle, our next session is supposed to be scaling, but using AutoCAD. Your exercise will simply be to draw this um, toilet in different scales. 1 is to 10, 1 is to 20, 1 is to 50, and 1 is to 100. So there are details. So therefore, you have to take note that the bigger the drawing, the more details shown. Okay, the smaller the drawing, the lesser the details. That's what I'm looking for. I will be posting this in Canvas with more details. For now, I'm just showing you um, what to expect. Okay, so please wait for the final instructions before asking me all the questions like sort of papers, etc., borders, names, where to put names. Wait for it first before you ask me. So this is the schedule that I mentioned to you. next meeting, scaling using CAD. Um, but I don't know whether we can do that. If we cannot do that, we might go ahead with the topic for next week, geometric construction lines. Um, I will also be sending out a survey form because I need to know a lot of things about your working condition at home. Okay, so that I can also adjust my exercises, and so expect that. No, this it's not graded. It's just a survey. Oh, this is nothing. Okay, very good. Um, Let me see. I'll just check the chat box. So there's nothing there. So well, it's 8:37. So are there questions, just in case? I'm trying to see. Oh, okay, so I think there's no questions. So that's all for this lecture. So if you have questions, you can always email me or send me a message in either Canvas or Google Classroom. Um, Again, please wait for the final instructions for the assignment. And as soon as I'm through checking all your papers, I'll submit them to you. I promise within this week. It's just been a very busy week last week. Um, Sir, do we need to get AutoCAD? I think you're expected to have AutoCAD. Um, but then, wait for final instruction because I cannot require you to get a license AutoCAD. It's very expensive. And I'm also not going to, at least since we're recorded, I cannot I cannot encourage you to look for pirated software. But then there are freewares, not necessarily AutoCAD, but almost the same, which we can use. So I've tried to confer with my with the other instructors if we can use that for instructional purposes, or whether there is a because the computer lab in USC, they all have AutoCAD and all the AutoCAD there are licensed, so we don't really have a problem with AutoCAD if we are there present in the computer labs, but you're not in the lab, you're at home. So we have to think about it. Unfortunately, the ones who prepared the syllabus was not prepared. You know? The version of AutoCAD, I think 2016 is enough because all we're going to do are drawings, line drawings. So let's just put that at, if you have AutoCAD 2016 to the latest is what we're going to use. Okay. Anything else? I'll have more details about the AutoCAD maybe within the day, maybe this afternoon. Yeah, that's a promise. Okay, so I guess that's it. All other questions about AutoCAD, please reserve it for tomorrow once I give out some details. Okay, so I'm going to turn off the recording now, and